Consider the compounds given here. First compound is named as 2-chloro-4-methyl anisole. Anisole is methoxybenzene C6H5OCH3. Since the compound is named as anisole, carbon carrying OCH3 group should be numbered as 1. Chlorine will be attached to the second carbon and methyl group will be attached to the fourth carbon. So that is why the name of the compound is taken as 2-chloro-4-methyl anisole. Now consider the next compound. Its IUPAC name is given as 4-ethyl-2-methyl aniline. Aniline is C6H5NH2. Since the compound is named as aniline, carbon carrying NH2 group should be numbered as 1. So we have methyl group attached to the second carbon and ethyl group attached to the fourth carbon. Alphabetical order is followed. So the IUPAC name of the compound is 4-ethyl-2-methyl aniline. Now consider the next compound. The IUPAC name is 3,4-dimethyl phenol. Phenol is C6H5OH. So OH carrying carbon should be numbered as 1. Methyl group is attached to the third carbon and we have another methyl group attached to the fourth carbon. So the IUPAC name of the compound is 3,4-dimethyl phenol. Isomerism can be divided into two types: structural isomerism and stereoisomerism. Structural isomerism is again divided into four types: chain isomerism, position isomerism, functional group isomerism and metamerism. Stereoisomerism can be classified into two types: geometrical isomerism and optical isomerism. Structural isomerism: compounds having the same molecular formula but different structures are called as structural isomers. So next we shall discuss about the various types of structural isomerism. Chain isomerism: chain isomers have the same molecular formula but different structural formula, and the difference in the structural formula is due to the difference in the number of carbon atoms present in the longest chain, or they differ in the carbon skeleton. Now consider pentane. The three different chain isomers are normal pentane, isopentane and neopentane. These three compounds have the same molecular formula C5H12, but the structure is different, and the difference in structure is due to the difference in the number of carbon atoms forming the longest chain. In normal pentane, the longest chain is with 5 carbon atoms, whereas in isopentane, the longest chain is formed with 4 carbon atoms and methyl group is attached to the second carbon. In neopentane, the longest chain is with 3 carbon atoms and 2 methyl groups are attached to the second carbon. So in chain isomers, the difference in structure will be due to the difference in the carbon skeleton. Position isomerism: when two or more compounds differ in the position of substituent atom or functional group on the carbon skeleton, they are called position isomers, and this phenomenon is termed as position isomerism. For example, consider the molecular formula C3H8O. It represents two alcohols, propan-1-ol and propan-2-ol. In propan-1-ol, OH is attached to the first carbon, whereas in propan-2-ol, OH is attached to the second carbon. So there is a difference in the position of the functional group present. Another example, consider 1-chloropropane and 2-chloropropane. These two are position isomers. There is a difference in the position of chlorine atom attached to the carbon atom. In 1-chloropropane, chlorine is attached to the first carbon, whereas in 2-chloropropane, chlorine is attached to the second carbon. Functional group isomerism: two or more compounds having the same molecular formula but different functional groups are called functional isomers, and this phenomenon is termed as functional group isomerism. For example, consider the molecular formula C3H6O. It represents an aldehyde and a ketone. Aldehyde is propanol CH3CH2CHO and ketone is CH3COCH3. Propanone and propanol are two different compounds. Propanone is a ketone whereas propanol is an aldehyde. So the functional group is different in both the compounds, but their molecular formula is the same, which is C3H6O. So this type of isomerism is known as functional group isomerism. Metamerism, it arises due to different alkyl chains on either side of the functional group in the molecule. For example, consider the molecular formula C4H10O. It represents methoxypropane and ethoxyethane. Both ethoxypropane and ethoxyethane are ethers. The difference is in the alkyl group which is present around oxygen atom. In methoxypropane, one methyl group is present on one side of oxygen atom and propyl group C3H7 is present on the other side of oxygen atom. Whereas in ethoxyethane, on both sides of oxygen atom, the functional group, two ethyl groups are present. So this type of isomerism, which arises due to different alkyl chains on either side of the functional group, is known as metamerism. So we have discussed about 4 different types of structural isomerism called as chain isomerism, position isomerism, functional group isomerism and metamerism. Next we shall discuss about stereoisomerism. The compounds that have the same constitution and sequence of covalent bonds but differ in relative positions of their atoms or groups in space are called stereoisomers. This special type of isomerism is called as stereoisomerism and can be classified as geometrical isomerism and optical isomerism.